Welcome back. We are discussing about wastewater treatment, under which we are talking about sewage quality parameters. In this video, we will be talking about some of the physical parameters of the sewage. The physical parameters, the first one is the odor. Fresh sewage does not emit any odor. Old sewage emits bad odors due to decomposition. And color, fresh sewage is gray in color, but older sewage is dark in color due to anaerobic conditions or septic conditions generated in the sewage. So by looking at this color and odor, we can quickly identify whether the sewage is fresh or old. And temperature of the sewage is normally higher than that of raw water due to the various sources from where it arises. In household operations, we are having cooking operations and some other boiling operations, and that water is discharged through the tap. When it comes out, it is having higher temperature than the raw water. So, like these industrial operations, they are also having higher temperature of water that may release into the drain, and thereby the temperature of sewage or wastewater is slightly higher than that of raw water. Usually, the temperature is higher than that of 20 centigrade. The temperature has a bearing on dissolved oxygen. Dissolved oxygen is nothing but the oxygen in the dissolved form in this raw water or a sewage. Whereas in raw water, the dissolved oxygen content is very high, whereas in the sewage, you're having a lot of organic material is there. We'll talk about later. These organic matter, they require oxygen for their survival and decomposition oxidation process. So thereby, whatever the oxygen is there in sewage, it will quickly get reduced. So this DO content is inversely proportional to that of temperature. Higher temperature indicates DO is likely less. And also depends on what type of contaminant load is there in the sewage. Highly organic load means a lesser DO. Inorganic load means there may not be much of organic loading, organic dissolved oxygen requirement. And sewage is now considered as a combination of some solids, very less percentage, uh, then more than water. So higher amount of water will be there, very small amount of solids are there. Solids in sewage contains inorganic solids, sand, silt, clay, dirt, etc. And organic solids are also there, carbohydrates, food materials, and then fats. And these type of things, they are now available in the solids in the sewage. The total solids is a combination of inorganic as well as organic. Inorganic solids, they do not undergo any decomposition at any stage. And so they are also called as fixed solids. Organic solids, they're often volatile and they'll evaporate at higher temperatures. So that's why they're also called as volatile solids. The total solids is equal to fixed solids plus volatile solids. Fixed means inorganic solids, volatile means organic solids. The total solids can also be categorized as total suspended solids, total dissolved solids, and total colloidal solids. Colloidal solids are having less than 1 micron size. And total suspended solids, they are nothing but which are floating in the water. And there can be some settleable solids also along with the suspended solids. The size of the solids, if you look at, the settleable solids are having a greater than 10 to the power of minus 2 mm. Suspended solids are having a size between 0.1 to 10 to the power of minus 3 mm. Colloidal and dissolved solids, they're having a size between 10 to the power of minus 3 to 10 to the power of minus 8 mm. So we mainly consider in the wastewater treatment these two solids, suspended and settleable, out of which suspended solids only they are mainly important here. We try to remove as much as possible these suspended solids. And similarly, when we are going to filter these samples in a container like this, using a filter paper, so some solids will retain here, some solids will be retained here, and some solids will be going into the uh, container as a filtrate. So now the filterable solids, they are nothing but the solids in the filtrate, and some solids which are there on the filter paper, they are called as suspended solids. These suspended solids, they are again fixed solids and volatile solids. How you are going to determine these solids? If you talk about total solids, they are mainly determined using gravimetric method. Gravimetric method means weight, using weight. That means you're taking a sewage sample, say in container or some container we take here, and then we take some volume of the sample here, and then the empty weight of the container W1 we are making here, say W1, and then we are heating it into a oven. This is a hot air oven, and it is heated up to 103 centigrade for 1 hour, so that all the water will get evaporated, leaving only some amount of the solids, say W2. The weight of solids is nothing but the difference of these weights, W2 by W1, and then volume of the sample is V. The concentrations in this water quality or wastewater quality, they're expressed in terms of milligrams per liter. So where W2 minus W1 is nothing but milligrams, and then V is volume in liters, so milligram per liter. And this sample is still there in this container. This we are keeping it in a muffled furnace where temperatures can go up to 1000 to 1200 degrees centigrade. So this is your muffled furnace. So now you are keeping this into the muffled furnace, and then what will happen at 550 to 600 degrees centigrade? The volatile solids are driven off, they get evaporated, leaving only the fixed solids. So the difference of W2 minus W3 will give you the fixed solids remaining, and then whatever the volume is taken initially, the ratio is going to give you fixed solids, and the difference of total solids minus fixed solids will give you the volatile solids. So now we'll look at a small problem. The sample is 100 ml here. So empty weight weight of empty container 25.455 grams. The weight of residue plus container after oven drying W2, and W3 is the weight of residue plus container after furnace heating. So first of all, we should take the difference of these two to get the amount of residue remaining after oven drying. So that is 30 milligrams, and divided by this 100 ml, this is volume. We should convert this into liters, so 10 by 1000 liters. So the ratio is coming to be 300 milligrams per liter. That is nothing but total solids. And the second step is now you take the difference of these two, oven drying and furnace drying, furnace heating, and fixed solids are remaining. So that is 20 milligrams, and 20 milligrams in same sample, 100 ml of sample, that is coming out to be 20 milligrams per liter. The difference of the total solids and fixed solids is the volatile solids concentration. Now you can see here the suspended solids. So here, this is also gravimetric method by weights, taking different weights at different stages of the test procedure. And we are here also, we are doing the same thing, taking a sample of known volume and filtered through a filter paper. A filtered paper here, we are using a filtered paper. Filter paper we are using here. And then some solids are there. So then the filter paper is heated in the oven and weigh the residue on the filter paper. Whatever the water is there, it will get evaporated, and then the weight of residue divided by volume of the sample. We are taking it here as the weight, the concentration of total suspended solids. And here you can see this is the methodology what we are going to use, because the size of the pores are very, very small. it takes a long time to filter out the solids. So this is the filtration assembly we are using here. So this is a conical flask, and you can see this is a small portion of the jar where sample is inserted in the jar here, and the graduations are there. We will know how much volume of the sample we have added. So this is volume number V, and then you can see a clamp here, and then this is the upper portion of the filter. There's a conical flask, and between the joint of the jar and the flask, we are going to keep a filter paper exactly to the size of this particular jar, and then you're keeping it over there, and then keeping clamps so that all both the upper portion and bottom portion, they're tied together. And when the water starts filtering through the filter paper, we are going to make use of a suction pump to increase the uh, separation of liquid and solid particles. So the liquid is going to separate it out, filtered out, leaving the residue on the filter paper. This residue is there, and then the water is still remaining on the top of the filter paper is removed through the oven. So this is the oven, and after that, the same filter paper with residue is now kept in the muffled furnace, and then the volatile solids are evaporated and leaving fixed suspended solids. And then we'll take the weight of this filter paper once again. The difference of the weights at after the oven drying and after the furnace heating will give you the amount of fixed solids present in the initial volume of V ml or V liters. So therefore the concentration is milligram per liter. And the difference of these two will be equal to your total suspended volatile solids. So let us take a small example to understand. Let us take a small sample of 10 ml in the jar, the upper jar. 10 ml means 10 by 1000 liters, and weight of empty filter paper 5.56 grams, and weight of filter paper residue after oven drying 5.5670, and after furnace heating this is 5.5650 grams. So difference of W2 and W1 is going to give you 7 milligrams. This is going to give you the amount of suspended solids present in 10 ml. So milligram in volume 10 ml or 10 by 1000 liters is going to give you 700 milligram per liter. And after the weight of difference between the second and third stage is going to give you 2 milligrams. 2 milligrams in the same volume, 10 ml of sample, is going to give you the concentration of total suspended fixed solids 200 milligram per liter. The difference of total suspended solids minus fixed solids going to give you total suspended volatile solids. And then the last one is the total settleable solids. So we are going to use a Imhoff cone. So you can see this is a cone shape having a volume of 1 liter capacity, and the readings are starting from the bottom 0 to 1000 ml at the top. So what we are doing is we are just keeping the sample into the jar up to the 1 liter mark, up to 1 liter mark, and then allowing these contents to stay there for around 45 to 90 minutes. And then all the solids will settle down after that period of time of settling. And then we'll mark this reading here. We'll note down this volume, whatever is the volume, say 10 ml here, up to 10 ml, for example. So the settleable solids concentration is 10 ml per 1 liter of sample. So this is how the settleable solids concentration is determined and represented. This particular cone is called as Imhoff cone. Thank you.